Ladies and gentlemen, in the last video we talked about standard additions, and we said that standard additions are very important for complicated samples. And we said that a standard in a laboratory that would just have benzene in it with the solvent isn't necessarily the same as a sample that contains benzene and multiple other things like a gasoline sample. So we said we can't really compare apples to apples. Sometimes there's no interferences at all, and these standards will work with the sample that's brought in. Other times, depending on what's present, right, and we said 70 to 80 other things in the gasoline case, these could interfere with the benzene and suppress or enhance the signals that we get from the machine. So we said we're going to have to figure out how on earth can we fix this problem, right? So standard additions come along, and standard additions are going to be our savior in the laboratory with these complicated samples. And this is how we do it. We know that we want to closely mimic the solvent that's inside of the sample. So what will happen is that a sample will be provided to me in a laboratory. And that sample we want to analyze for something. In the gasoline case, let's just keep the trend going and let's say that we want to look for benzene. But I am not going to put 70 to 80 components in my standards to make it similar. So what happens is that I'll take my sample and I'll just take my sample as it is. Nothing there. And then I'll take some sample and I'll put it into a volumetric flask. But before I do that, I'm going to add a little bit of benzene. I'll know how much, so the volume I'll know. And if I know the volume of benzene, or if it was a solid, the grams of benzene, I know how much is present in that volumetric flask, right? And then I'll turn around and I'll use my sample as the solvent. So what has happened is that I've taken the sample that's provided to the laboratory, I have added, standard addition, a little bit of what I'm looking for into the volumetric flask, and I've used the sample as the diluent all the way up to the flask. All right, well, if that works, that's my first standard. I can do the second standard the same way. I'll add a little bit more benzene, more volume. If it was a solid, more gram. And I'll dilute up to the line with the original sample. Instead of just a normal methanol or acetone or cyclohexane, the solvent is the sample. And then I could do a third one, right? I'll add more and more benzene, even more than before. And I'll dilute it to the line with the sample. So this is going to be regarded as my standard number 1, and this is regarded as my standard number 2, and this is regarded as my standard number 3. The sample on its own, the sample is referred to as the blank, the 0 one. So let me just recap for just a few seconds. I've been given a sample in the laboratory. I'll take it as it is. I'll pour out a portion of it, and that is my blank. Then in one volumetric flask, I will add a little bit of the component that I'm looking for, in this case benzene. And then I will dilute up to the line with the sample that was brought into the lab. The second standard is made by adding even more benzene, dilute using the sample. The third standard is adding more benzene and dilute using the sample. That's what we've done. Now, look at what was happened. we have a set of standards here, 1 and 2 and 3, that is very similar in composition to the sample that was delivered to the lab. Basically, if this was all gasoline, this is gasoline plus a little bit of benzene that I added. There's your standard, there's the addition. This is another standard. It's gasoline with a little more benzene. There's your standard, there's your addition. And then this is another standard. It's gas that I've added even more benzene than before. And there's the standard, and there's the addition part. So that is the proper way to prepare a standard addition analysis. Your sample will be used as the solvent, and you will add little bits and little bit more and a little bit more than that to make your set of standards with. Very similar to a set of standards, right? The only difference, it's the solvent. The solvent is the sample that you're using, and the reason is because we want this similar composition across the board. So now all of these flasks have those 70 or 80 components in it. In standard 1, I've got a little bit of benzene than what wasn't there before. Standard 2, I've added a little more. Standard 3, I've added more than that. Now we've got to figure out how to handle this. What do I need to do? I mean, all of these flasks has multiple components. I've added benzene, more and more and more of it in the standard flask. How on earth do I handle this type of process? How do I make a calibration curve with it? Well, you'll find that out in the next video.